Hi, welcome back to Trigonometry. So I figured out a way to set up my tripod at home, and I have my whiteboard here. It's not as big as what I have in the classroom, but I think it's good enough. So for this lecture, I just want to continue with the some more trigonometry equation. I think trigonometry equation is very important, and you need to do more problem in order to be good at it. So I give you some example, and I want you to go through that carefully with me, okay? And after you watch the video, make sure that you understand it and you redo the problem, okay? So let's continue with our so last time in the second video we do two problems. So I'm gonna do another two problem. So what I have over here is, let me see. I'm gonna pick the one that's pretty simple. It's not really that hard. Just require you to use some property we already learned. So I have sine cube of x, okay, plus cosine cube of x, okay, equal to sine x minus cosine x. Yeah, my allergy is still killing me, you know, and I'm kind of afraid of going outside a little bit because during this time and the virus spreading, right, people thought think that I got a virus, so it's good to be staying at home, you know. Okay, so I have sine cube of x plus cosine cube of x equal to sine x minus cosine x. So how are we gonna do this? And I want to solve for x. I want to solve for x also. Okay. Okay, so solving trigonometry equation, it requires you to think a little bit. You know, at the beginning, you don't know where you should start with. You know what formula you should use, but over the time, when you get used to it, when you memorize all the formula property, then the method just come into your brain right away. Okay, so solution. Okay, so I see that this is sine cube and this is sine, right? So maybe we can factor some way somehow, because but in order to factor those, we need to bring them together, right? So I'm not really sure this will work, okay? But we have to try. We have to try. Sine cube of x minus sine of x. So I bring everything to the left. Okay. Plus cosine cube of x plus cosine x equal to 0. So I bring everything to the left hand side. Okay. Then what? Then I see that oh, this is sine. I'm sorry. This is sine, cosine. Oh yes. Okay. Then I see that this and this, there's sine of x in common. I'll take them out. So I have sine x squared minus 1 plus I also see cosine of x in common. I take cosine of x out, so I have cosine of x squared plus 1 equal to 0. Okay. And sine squared of x minus 1, I see if I use the Pythagorean identity, I can change this to cosine squared, right? Because sine squared plus cosine squared is 1. But this is cosine squared equal to 1 minus, but this is sine squared minus 1. So I just need to put the minus sign in front, right? So to give you negative sine x cosine. Because when you put the negative sign in front, you can shift the position. Okay? Plus cosine x cosine squared x plus 1 equal to 0. Okay. And now we have two terms. Okay? We have two terms separated by a distant sign. We also see that cosine x is cosine x over here in common, so I take cosine x out. Okay? So what you have left is cosine squared plus 1, okay, minus sine of x. equal to 0. So I successfully manipulate the original function, original equation to something that is in product form. That is our goal, right? You remember the first video of 70 trigonometry, so we want to bring it to the product form. Because as long as you bring it to the product form, you can apply zero product property. So this is equal to cosine of x equal to 0, or cosine squared of x plus 1 minus sine of x equal to 0. This is very easy. Cosine of x equal to 1, cosine of x equal to 0. So you draw unit circle. So this is cosine here, 0 right here. So cosine of x equal to 0, you move the angle. This is initial, this is terminal, so it must be 90 degrees, right? And negative 90 degrees. Okay, if you go clockwise. So I can write this as x equal to pi over 2 plus, so from this position to this position I add pi, right? Then I add another pi, go back to this position. And I keep adding pi to go back to switch between the first position here and the second position here. So I add k pi. Okay, that's it. K could be 0, you see k 0 give you pi over 2. K equal 1 give you 3 pi over 2. 3 pi over 2 is this. Because pi over 2 plus another pi give you 3 pi over 2. Okay, and 3 pi over 2, it is counterclockwise. If you write it in clockwise form, it will be negative pi over 2. Okay, so I done this. So this is one of my solutions. All right, now go back to this. Now I have cosine squared, I have sine. So what should we do here? Okay, that's very easy. Very easy. Well, I think I missed something, right? I think I missed something. Cosine square. No, I'm good. I'm good. Okay. So you see it over here. This one I can change to sine square. 1 minus, right? Plus 1 minus sine x equal to 0. So 1 plus 1 gives you 2. So 2 minus sine square x minus sine x equal to 0. Okay. And I can change the sign. Give you sine square x plus sine x minus 2 equal to 0. Okay. What is this for? This is a quadratic form, right? Square a here, x square, x, and c, right? It's a quadratic. So all you have to do is you try to factor it. Okay, so you have to see it factorable or not. If it's not factorable, we have to use a quadratic formula. Okay, so what do you think? Is this factorable? It's minus 2. Okay, it's minus 2. So I have 1 minus, so I have this, right? Sine x plus 1 times sine of x minus 1. It will? Minus 2. I'm sorry. Nope. So how about like this? Or maybe it's not factorable. How about 2 minus 1? Okay. 2 sine x minus the sine x. Yeah, right? It worked, right? But we need to check. We need to check if we got something wrong over here now. Okay, let me see. Just before we jump to the our final answer. Okay, I flip them over here. I check it. Then do sine, cosine cube, plus cosine, right? So I factor them out. So sine square minus 1, a factor of cosine squared plus 1, right, sine squared, 1 minus rest cosine. Oh, you see, there's something wrong right here. It should give you cosine squared. There you go. That's why. So this is give you sine. So I'm sorry. So this one should give you, see, we always have to check, because there's always something wrong, okay? So I factor cosine out, so I have another cosine here. There you go. Okay. Because this is cosine square, I just take out one cosine, we still have another cosine left. Okay, so this is really a little bit harder. So if we change it to 1 over sine squared, then we still get stuck with this. So we have to say again, you have to check. You have to say, check like what method, what approach should be feasible. Because if I change it to cosine squared, 1 minus sine squared, 1 minus sine squared, 1 plus 1 is 2. It's like you playing chess, you know, you have to think in advance. There's no way we can factor anymore. So how about this? I recognize that if I divide both sides by cosine square, this is give you 1, this is 1 over cosine square, this give you sine over cosine because this 1 over cosine. Look at that. I divided with cosine square. Okay. Now this is give you 1, right? 1 plus cosine, 1 over cosine square. And this is cancel, you have sine over cosine equal to 0. But sine over cosine, if you tangent, right? You tangent, and 1 plus cosine square is what? 1 plus tangent square. Right? We really learned that. Okay, the formula is give you tangent square equal to 0. And now we have what? We have 2 plus tangent square. It still gives you another quadratic, right? So tangent square, I'm going to write over here, tangent square x minus tangent x plus 2 equals 0. This is quadratic. And do you think we can factor it? Can we? I don't think so. Because I checked the quadratic formula, you have negative b, I checked that negative b is negative b over negative 1 should be 1 plus minus square root of b square is 1 square minus 4ac, you see here, over 2a. This is give you 1 square is 1 minus 8, negative 7. So we don't have a real number. Okay, so this is not factorable. And because it's not factorable, we don't have any solution here, so no solution here. Alright, so your only solution is this one. Okay, so everybody clear? Alright, alright. Yes. So that is the method. I already told you in the first video that we try to bring it to the product form. Okay, you have to. You have to use your property to see which one is the best way. You must be able to think in advance. Okay, and in order to be able to do that, you have to work a lot of problem. That's why I give you another example here, so that you have more chance to work on a problem. Okay, and make sure you know how to get the basic one. You need to know how to do the basic equation first. Okay. Okay, let's see if we can do another example. Okay, let's see. So I'm gonna sit here. Okay, erase this. You know, sometimes I think that you guys like this too. You know, you do the video online. It probably make you kind of lazy a little bit because you don't have to go to school. But the thing is that you still have to do work. You have to submit homework. You also have to submit assignment. We probably have only one more assignment. So lucky you. And because of the virus, so you're lucky because I'm going to throw away 2 assignments and you have only 1 left. Okay? Let's do another one. How about this one? 3 sine x plus 2 cosine x, okay, equal to 2 plus 3 change in x. Alright, so I give you a couple minutes to think about how to do this, okay? I'll be back. Okay, so what do you think? We have sine, cosine, we have tangent. We know there's a relation between tangent and sine, cosine, right? And you have to think about that. Tangent is sine over cosine. If I change the sine over cosine, find least common denominator, then maybe we can do something. So I change it. Sine over cosine. Okay. Then I find least common denominator for all the terms. Okay, so it becomes 3 sine x cosine x plus 2 cosine square x equal to 2 cosine x plus 3 sine x. So I find LCD, okay, least common denominator, and multiply the top and bottom by cosine. Then I throw away the cosine. Okay. So I have cosine, 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 sine, sine. So I bring everything to the left hand side. Let's see if we can factor something or not, okay? So I have 3 cosine squared plus 2 cosine x plus, oh, this is minus, sorry, we gotta bring over here, 3 sine x cosine x, okay, minus 3 sine x equal to 0. Okay, what next? You will see that this and this has something in common, right? I can take them out. So before I do that, I just want to check if I have everything's correct or not. Everything's good. Everything's good. Oh, I have this minus that. Okay, so this is positive. See that? It's positive. Okay, so I factored up this. So I have 2 cosine x now. So I have cosine x minus 1. The reason I factored it because I see it in advance, and when I factored it, I see cosine x minus 1. When I factored it, I also see cosine x minus 1. Oh, see that? I can see it in advance, and you should train yourself with that too. It's like you're playing chess. You have to think in advance. Okay? I see that, and after I factored them out, there's something in common one more time. So I have cosine x minus 1 in common, and what I have left is 2 cosine x plus 3 sine x equal to 0. And now what? I successfully manipulate the original equation to the product form equation. So I can split up cosine x minus 1 equal to 0, or 2 cosine x plus 3 sine x equal to 0. This one should be easy. Cosine x equal to 1. So I'll draw a circle. This cosine here. 1 right here, right? It's 0, right? It's negative 1. So cosine to 1 should be cosine 0, the angle will be 0. The angle will be 2 pi. Cannot pi, okay, because pi gives you negative 1, 2 pi, 4 pi, 6 pi, right? So your answer will be what? X will be k pi. No, 2k pi. Right? Because if k equal to 0, if you 0, k equal to 1, 2 pi, k equal to 2, 4 pi. So your answer will be 2k pi. Okay, general answer. With k equal to 0, plus minus 1, plus minus 2, and so on. Now let's back to this one. I say that if I subtract both sides by negative 2 cosine x, right? Then I divide both sides by cosine x, so I have tangent, right? Tangent of x equal to negative 2 over 3. Okay. Tangent of x gives you negative 2 over 3. Okay, so how we show this? Of course, negative 2 over 3 over here is not a special value. It's not a part of the table. So what you have to do, because tangent, the range of the tangent, you know, is negative infinity to positive infinity, so which is good, okay? So x over here should be inverse tangent of negative 2 over 3, okay, plus k pi, because the period of tangent is pi, okay. Okay. So this will be your second solution. Okay. So for this equation, we have two solutions. So this is a very special case, you see, because this is not special value. So because it's not a special value, you cannot get the special angle. We just take the inverse tangent of that. And you can use scalar, you can bring it to the degree, but I mean, if you write it like this, that's good enough. It means you really understand it. Okay, and again, you see that this problem here, we have to bring it to the product form. So that is your goal, okay? Bring it to the product form. You can bring it to the quadratic formula form first, then factor them, it's still product form. Okay. And if you guys have any questions, try to understand the unit circle, let me know, okay? Alright, so I think that's all for the video today, so the part 3 of the video. So I give you 2 more examples. I want you to go through this carefully, redo the problem, try to understand it, okay? And because the thing that you have a lot of change to do many problems over a short period of time. So I think this is a very helpful way for you to train yourself. In the homework, I already assigned some trigonometry equation already. So go ahead, try to do all of them. Okay, and make sure you have to put the question if you have any. Okay, do not hesitate. Don't be afraid that you ask something like crazy, stupid. That's fine. Because so far I have not seen any question on the discussion board. So that's what I want you to do, okay? Because everything will be online now, so everything we can interact with one another online only. Okay, we can Zoom, but I don't think you guys have time for that. So, and it's not gonna help much because in my opinion, I think Zoom app is, we cannot write it. You know, we can talk like that. It's good for speech class or history, but I mean for mathematics you have to practice. Okay, so please let me know if you have a question. Email me, put your concern, your discussion board. Then I think everything will be alright. Thank you so much, and I'll see you next time.